Yes, hello friends. Today I'm going to talk about water treatment, and we're going to talk about a concept called dissolved oxygen. Throughout our discussion, we're going to talk about dissolved oxygen. Dissolved oxygen is going to be symbolized as DO. DO. And DO will stand for dissolved oxygen. So what is dissolved oxygen? Dissolved oxygen is the amount of oxygen present in water. So what is dissolved oxygen? Is that amount of oxygen present in water. So dissolved oxygen is got from atmosphere and from aquatic plants. So that means when there is re-aeration from the atmosphere, it increases the amount of dissolved oxygen in the river or the channel. Also from aquatic plants, when plants carry out photosynthesis, that means they use what? Carbon dioxide, and they produce oxygen. So in those aquatic plants, in that process of using carbon dioxide and to produce oxygen, they increase the amount of oxygen in the water. So that amount of oxygen in the water is called dissolved oxygen. So today we're going to analyze dissolved oxygen for certain river Malaba. This example here, I'm going to show you how to calculate the dissolved oxygen in a river. How do you calculate the dissolved oxygen in a river? Let's find out from this example. Given the following parameters for river Malaba, so given QW stands for the flow rate of the wastewater. QW is the flow rate of the wastewater. Is given as 0.2 meters cube per second. Then QR is the flow rate of the river. R stands for the river. And the river is River Malaba, which is 0.43 meters cube per second. Then our LR stands for the ultimate biochemical oxygen demand, BOD. Ultimate BOD of the river, which is 5.0 milligrams per liter. Then DOR is the dissolved oxygen. I will say that our DO stands for dissolved oxygen. DOR is the dissolved oxygen of the river, which is 6.5 milligrams per liter. Then DOW is the dissolved oxygen of the wastewater. Our W stands for wastewater. Our R stands for the river. So that means DOW is the dissolved oxygen of the wastewater, which is 1.0 milligrams per liter. Then now this LW, W stands for wastewater. That means now our LW stands for the biochemical oxygen demand, BOD. The biochemical oxygen demand of the wastewater, which is what? 596 milligrams per liter. So given these parameters, we can now compute the dissolved oxygen and initial biochemical oxygen demand after mixing. So you'll know that in this example, let's find out the solution. The wastewater will mix with the river, assuming this represents the what? The wastewater. This represents the wastewater. Now, when the river is flowing, now our river is river what? River Malaba. So when River Malaba is flowing, it will meet the wastewater. After meeting the wastewater, they will mix up. After mixing up, we are going to find the dissolved oxygen DO after mixing. After River Malaba mixing with the wastewater, we're going to find the dissolved oxygen DO. DO is the dissolved oxygen after what? Mixing. Let's find out. Our solution will be number 1, the dissolved oxygen DO. DO stands for dissolved oxygen. After mixing, the dissolved oxygen after mixing is given by the Q of the wastewater. Q stands for the flow rate of the wastewater times the dissolved oxygen of the wastewater plus Q is the flow rate of the river times the dissolved oxygen of the river over the total discharge after mixing, because the discharge or the flow rate of the wastewater plus the flow rate of the river. This after what? Mixing. So let's substitute. We have our QW is the what? Flow rate of the wastewater. Let's substitute. Our QW from our question, it is 0.2 times our DOW. It was given a question, it is 1.0 plus our QR. Our QR is the flow rate of the river. It was given as 0.43 times our DOR is the dissolved oxygen of the river, that river Malabar. So what's the value? The value is 6.5 divided by our QW. Say QW is the flow rate of the wastewater. What's the value? The value is given as 0.2 plus QR is the flow rate of the river, which is 0.43. So when you compute that very well, that means our dissolved oxygen, DO. DO stands for dissolved oxygen. So what's the dissolved oxygen? After computing that, we shall find that our dissolved oxygen is going to be 4.75 milligrams per liter. Now that's very important. After finding the dissolved oxygen for mixing, our question says we should also find the initial BOD after mixing, the initial biochemical demand. Let's find that one also. Round number 2, we are finding the initial biochemical oxygen demand after mixing. So this one, let's call it LA. So LA stands for the initial biochemical oxygen demand. So it's given by the formula is given by the Q of the wastewater times the L of the wastewater plus the Q of the river times the L of the river over the Q of the wastewater plus the Q of the river. What did we say? Our Q stands for the flow rate of the wastewater. Our LW stands for the ultimate BOD or the ultimate BOD of the wastewater. Then our QR stands for the flow rate of the river. Then our LR stands for the ultimate BOD of the river. Just know R, river, W, wastewater, because the river is mixing the what? Wastewater. Let's substitute. Now our initial ultimate LA is given by our QW is given. It is the what? The flow rate of the wastewater, which is 0.2 times. Our LW is the ultimate BOD of the wastewater, which is what? 26.596 is given, plus our QR is given. Our QR is 0.43 times. Our LR is 5 over the sum. The sum is what? Is 0.2 plus 0.43. Now, on substituting and on computing, our initial ultimate is given by 11.86 milligrams per liter. Thank you very much for watching this video. See you next time.